Hello students, welcome to Wandukam. In this video, we will discuss about reference electrodes. So first we should know what is reference electrodes and why we are using this reference electrode and the importance of this reference electrode in a cell. So you know, for making a 1 gram galvanic cell, we need 2 electrodes or 2 half cells. And the potential which is obtained from that cell is your cell potential. If the potential of one electrode is known, suppose this is anode electrode potential of anode is known, then from the cell potential we can find out the electrode potential of this cathode. So reference electrode can be used as anode to determine the potential of cathode. So this is the function of reference electrode. The potential of reference electrode is stable and this is constant. So whenever we want to know the potential of unknown electrode, then it has to be connected with a reference electrode to form a cell. So we can find out the cell potential. From the cell potential we will find out this electrode potential of this electrode. So here I have written for anode. It is not that necessary to make always reference electrode as anode. It can also be made cathode depending upon the other electrode and its material. So there are two types of reference electrodes. One is the primary reference electrode and second type of reference electrodes are secondary or subsidiary type of electrodes. An example of primary reference electrode is standard hydrogen electrode, or this is also known as She. And this electrode is your primary reference electrode because the output potential is 0 volt for standard hydrogen electrode. Let us discuss some important features of this standard hydrogen electrode. That means about the construction and working of this electrode. This is the diagram for standard hydrogen electrode. You can see one inverted glass tube with a bell-like structure at the bottom. This tube consists of a platinum wire with a platinum foil covered with the platinum black at the bell. This tube is dipped into 1 molar solution of hydrochloric acid and hydrogen gas is allowed to escape from this platinum surface. This hydrogen electrode is also known as standard hydrogen electrode because both hydrogen gas as well as hydrogen ion are in their standard state, that is 1 atmospheric pressure, 25 degree centigrade temperature and 1 molar H plus ion concentration or HCl. And the electrode potential of this electrode is 0 volt at all temperature. So the potential of other electrode can be determined by connecting that electrode to the standard hydrogen electrode to form a galvanic cell like this, where this is the electrode whose potential is to be determined. So it is connected to standard hydrogen electrode to form a cell and the cell potential is determined. In this case, the cell potential is the potential of unknown electrode as the electrode potential of standard hydrogen electrode is 0 volt. So in this way, the single electrode potential is determined by using a reference electrode. But however, standard hydrogen electrode has certain limitations, such as the construction is very difficult. It is impossible to maintain the unit activity for both hydrogen ions in solution as well as the hydrogen gas at 1 atmospheric pressure. In presence of small impurities, the electrode becomes inactive as platinum absorbs impurity very easily. So to overcome these limitations of standard hydrogen electrode, secondary or subsidiary reference electrodes are considered. The example of secondary reference electrodes are CALOMEL electrodes and silver chloride electrodes. These electrodes are also having constant and stable electrode potential. We can also say that they have invariant potential. So in my next video, I will discuss the construction and working of CALOMEL electrode and how it is used to determine the potential of unknown electrode with example. This is very, very important secondary reference electrode. So keep watching, keep learning. Thank you.